Hello my dear students, once again I am here. I'm very sure you might have enjoyed your Diwali vacations well and you are preparing for your exams in better manner. Now, before our exams, we would like to finish one more chapter, that is chapter number 17, continuity. As we have finished limits before Diwali, so this chapter is quite based on limits only. Most of the things will be related with limits and few things will be added. So what is continuity? A function fx is said to be continuous at a given point a, x is equals to a, if f a exists. The first thing is that f a should exist. Second thing, that limit x tends to a, fx exists. And third thing is that limit x tends to a minus is equals to limit x tends to a plus fx is equals to fa. So if these three things exist simultaneously, then we will say that a function fx is continuous at the given point x is equals to a. And if these are not equal, then we will say that function fx is discontinuous. The function fx is discontinuous. If this does not exist, if this is not equal, then we will say that the function fx is discontinuous. Now, in discontinuity, there are various types of discontinuity. For example, if left hand limit of a function is equals to right hand limit of a function is not equals to fa, then it is called removable discontinuous. It is called removable discontinuous. Similarly, in second case, if limit x tends to left hand limit of a function is not equals to right hand limit, then it is called discontinuity of first kind. Similarly, if the function either left hand limit or right hand limit or both does not exist, then it will be known as discontinuity of the second kind. Left hand limit of a function or right hand limit of a function or both does not exist, then it is discontinuity of second kind or type. Okay, then what else is there? Two more things are there. One is left continuous and another is right continuous. Left continuous is if left hand limit is equals to fa, then it is known as left continuous. Left hand limit is equals to the function, then it is known as left continuous. And if right hand limit is equals to the function, then it is known as right continuous. So like in limits, we have find out the left hand limit and right hand limit. So the only three things we will have to do. Every time we will have to find right hand limit, left hand limit and the value of the function. If all of them are equal, function will be called continuous. If right hand limit and left hand limit is not equal, then it is discontinuous of discontinuity of first kind. And if function none of the right hand limit left hand limit does not exist, then it is of second kind, left continuous and right continuous. So these are the all things which you will have to do. Let us see the questions. It's not a very big chapter, so within 3 lectures, I would like to sum it up. So I have planned it in such a manner that I could finish it in 3 of my lectures. And since your exams are approaching, so I'm not going to make a very big lecture for you. All the 3 lectures will be very small. Let us see the first question. The first question is, yes, here we go. Test the continuity of the following function at the origin. Origin means x is equals to 0. So function is given as fx is equals to modulus x upon x and 1 when x is not equals to 0 and when x is equals to 0. So what we will have to understand that what is the meaning of this modulus. This modulus means that every time you will have to do it in such a manner that when x is less than 0, the value of modulus will be minus x, and when modulus x is more than 0 or more than 0, then it will be x upon x, and when it is x is equals to 0, the value of the function is given as 1. So here the value will be minus 1, here the value will be plus 1. Now left hand limit, we want to check the continuity at x is equals to 0. X is equals to 0 पर हमें continuity check करनी है. So limit x tends to 0 fx, left hand limit, so 0 minus, that is limit h tends to 0 minus, that is f0 minus h. So when it is less than 0, the value of the function is minus 1. So limit h tends to 0 minus, that is minus 1, and hence the value of this limit, left hand limit, is minus 1. Similarly, we will check the right hand limit, that is limit x tends to 0 positive fx. So right hand limit is h tends to 0 positive f0 plus h. The same thing we have done in limits. So same thing we are going to do here. The value of the function, and when x is greater than 0, is positive 1. So it is positive 1. And so we come to know that left hand limit is not equals to right hand limit. Hence the function is discontinuous of first kind. Limit x tends to 0 positive fx. So function fx is discontinuous of first kind. Discontinuity of first kind it is. So every time you will have to do it in this manner only. The only thing you will have to take care of this modulus x. So whenever there is modulus, at x is equals x less than 0, its value will be minus, and x plus more than 0, its value will be positive. Okay, so this was the first question, and let's look for the second one. This was question number 1. Let us see the second. Now in question number 2, what he is asking, show that the function given by this is discontinuous at x is equals to 0. So at x is equals to 0, this is the discontinuous. What is the function? Fx is equals to e to the power 1 upon x minus 1, e to the power 1 upon x plus 1 and 0 at x not equals to 0, at x is equals to 0. So where you will have to prove that the function is discontinuous at x is equals to 0. Now here the thing to understand is that if limit h tends to 0, 1 upon e to the power 1 upon h will be 0, because 1 upon e to the power 0 will be infinite, 1 e to the power 1 upon 0 will be infinite, and e to the power infinite will be infinite, and 1 upon infinite will be 0. Okay, so once again I will check the left hand limit. Limit x tends to 0 negative of the function fx, then limit h tends to 0 negative f 0 minus h. 0 minus h is nothing but minus h only. So limit h tends to 0 negative f minus h. So when I will do f minus h, it will become limit h tends to 0 negative e to the power minus 1 upon h minus 1 e to the power minus 1 upon h plus 1. And since the exponential, this power is negative, so if it will be in the denominator, it will be positive. So what I'll write it, limit h tends to 0 negative 1 upon e to the power 1 upon h minus 1, 1 upon e to the power 1 upon h plus 1. And now if I will substitute h tends to 0, I'll get 0 minus 1, 0 plus 1, and hence the answer is minus 1. So the left hand limit, value of the left hand limit is minus 1. Now let me check the right hand limit. Limit x tends to 0 positive, that is fx. So limit h tends to 0 positive, I'll have to check the value of 0 plus h. 0 plus h is h only. So limit h tends to 0 fh. What I'll do now, limit h tends to 0 positive, I got e to the power 1 upon h minus 1, e to the power 1 upon h plus 1. 1 upon h I cannot do this because that will be infinite. So what I should do, I should divide both of the numerator and denominator by e to the power 1 upon h, so that I'll get it limit h tends to 0 positive 1 minus 1 upon e to the power 1 upon h, 1 plus 1 upon e to the power 1 upon h. Now I'll substitute the limit, that is h tends to 0. So I will get 1 minus 0, 1 plus 0, answer is positive 1. I came to know that limit, left hand limit is not equals to right hand limit. So the function is discontinuous. And discontinuity of first kind. So function is discontinuous. That's the same thing we will have to prove, and of first kind. Now let's see the next question. This was question number 2. Let us see question number 3 now. What question number 3 is asking to us? Discuss the continuity of the function fx at x is equals to 1 by 2. This continuity you will have to discuss, that is it continuous or discontinuous at x is equals to 1 by 2. The function is given as fx is equals to 1 by 2 minus x when x is between 0 and 1 by 2. When x is greater than equals to 0 and less than 1 by 2. The value is 1 when x is equals to 1 by 2, and value is 3 by 2 minus x when x is greater than 1 by 2. When x is greater than 1 by 2, and it is given as greater than 1 by 2 and less than 1. 1 by 2. X is greater than 1 by 2, less than 1. At x is equals to 1 by 2, we will have to check its continuity. Okay. So to check the continuity, what I'll have to do? I'll have to calculate the left hand limit and right hand limit. Limit x tends to 1 by 2 minus fx. That is limit h tends to 1 by 2 minus f. H tends to 0, sorry. 1 by 2 minus h. I got at 1 by 2 minus h is less than 1 by 2. So the value of the function will be this. So in this, in place of x, I am going to substitute 1 by 2 minus h. So limit h tends to 0 negative. I got 1 by 2 minus 1 by 2 plus h. 1 by 2 and 1 by 2 is cancelled. I got h tends to 0, so the value of the function is 0. Now similarly, let me check the right hand limit. Limit x tends to 1 by 2 positive at fx. So I got limit h tends to 0 f 1 by 2 plus h. Now 1 by 2 plus h means the value of function is more than 1 by 2. So at more than 1 by 2 the value of the function is this 3 by 2 minus x. So limit h tends to 0 3 by 2 minus 1 by 2 minus h. And here what I got, 1 minus h. Limit h tends to 0 1 minus h, and if h is equals to 0 the value of the function is 1. So what I got, that left hand limit is not equals to right hand limit, so fx is not continuous at x is equals to 1 by 2. Limit x tends to 1 by 2 minus fx is not equals to limit x tends to 1 by 2 plus fx. So fx is not continuous. And having discontinuity of first kind. Okay, so this way we have solved equation number 3. Most of the questions are like this only. Every time you will have to check. All the questions till now are discontinuous only. We could not get a continuous function, but surely you will get some time. Let us see the next question. That is question number 4. So question number 4 of mine is saying, discuss the continuity of the function fx at x is equals to 2. So fx is to be checked as 2 minus x, 2 plus x. When it is 2 minus x, when x is not less than 2, and when x is more than 2 and equals to 2. The function is this. At x is equals to 2, you will have to check the continuity. So simply limit x tends to negative, that is fx, left hand limit. So limit h tends to 0 f 0 minus 2 minus h. So 2 minus h is less than 2, so the value of the function will be 2 minus x. In this, in place of x, I am going to substitute 2 minus h. I got limit h tends to 0, 2 minus 2 plus h. 2 and 2 is cancelled, and when h is 0, I got the value of the left hand limit as 0. Similarly, I will get the right hand limit now. Limit x tends to 2 positive fx, that is limit h tends to 0 f 2 plus h. 2 plus h means the value of fx is more than 2. So in more than 2 we will take the case this one. So in this 2 plus x it was? Yes. Limit h tends to 0, 2 plus h. It become 4 plus h. When I kept h as 0, I got the value of the function as 4. So once again, we got a discontinuous function. Limit x tends to negative fx is not equals to limit x tends to positive fx. Hence, we can say that the function is discontinuous, and discontinuity of first kind once again. Okay, let us try to solve one more question. Let me try to look for a continuous one this time. All are discontinuous. Yes, let us take question number 6. So what question number 6 is saying, that show that the function is continuous at x is equals to 0 and the function is given as fx is equals to 2x minus modulus x. And once again the modulus is there. So I told you that its value will be negative when x is less than 0 and its value will be positive when x is greater than 0. So function, redefine the function and write it like this, that 2x minus x when x is less than 0, or 2x minus plus x when x is greater than 0. Okay, greater than equals to 0. Okay, so now at x is equals to 0, I will have to check the function. You can write it once again. I got it. 2x plus x is 3x and 2x minus x is x. So at x less than 0, it is 3x. At x more than 0, its value is x. Left hand limit x tends to 0 negative, that is fx. So limit h tends to 0, f 0 minus h, and in place of x I am going to substitute 0 minus h. I got limit h tends to 0 minus 3h, h tends to 0, so I got the value of the function as 0. Similarly, limit x, right hand limit I am going to calculate. So limit h tends to 0, f 0 plus h, and when it is 0 plus h, the value of the function will be x. So limit h tends to 0, 0 plus h, that is once again 0. So first time we got the value of left hand limit and right hand limit equal. So in that case I will have to check the function also, f0. Okay, f0 means when the value of the function is equals to 0 is x. So in x I will substitute x as 0. I got the value of fx also, f0 also equal. So first time we can say that left hand limit, right hand limit, and the value of the function is equal to 0. So the function is continuous. So fx is continuous. So we are having the questions like this. We will discuss few more questions in tomorrow's video, and thereafter in the live class we will finish off the second exercise, finish off this much work and keep preparing for your exam well.